A very good morning, ladies and gentlemen. I'm Brendan from NUS ISS under Data Science Practice.
Hi, good morning. I'm Christine from Data Science Practice. Welcome to the webinar. Let's get started with today's webinar.
Let's go to the slides. Product and pricing analytics for commercial excellence. It is the essential data skill set required by every single data scientist. Once again, a very good morning to all of you. Thanks for joining us for this webinar session. A typical business organization will make full use of data via data science and decision science to improve their competitive advantage in the marketplace. As you can see, traditionally, data is being used to present in terms of dashboarding or reporting. Now, it is crucial for them to make decisions via data to be presented at the right information to the right person at the right time with the right quantity and right quality at the right place. So these are the data being used to derive business insights. However, recently, decision intelligence become one of the most important framework to integrate and intersect between decision-centric as well as data-driven organization. Now, this will further improve the decision-making process by a typical organization. Ladies and gentlemen, as you know that in terms of analytics maturity model, it started with descriptive analytics, basically to explain what happened. Subsequently, we can carry out diagnostic analytics, which is explore how it happened, and subsequently predictive analytics to explore further what's going to happen next in the near future. Unfortunately, all this doesn't specify the recommended action to be taken by the human being. With that, all companies are pushing the limit in terms of the capability for prescriptive analytics, which basically be able to propose actionable item for them to take so that the final decision maker are well informed in their process in terms of decision making. If you're looking at the hierarchical data structure, data is being transformed from raw, meaningless data into information, knowledge, wisdom, as well as decision. Now, these are in line with the analytics maturity model from descriptive analytics, diagnostic, predictive, and all the way to prescriptive analytics. Moreover, it is very crucial for us to look at the data journey from data collection, from raw data, to data integration, and subsequently data analysis via AI techniques, machine learning, deep learning, and etc. So in a nutshell, in terms of predictive analytics, there are three main categories of predictive techniques, namely prediction, forecasting, and simulation. On the other hand, for prescriptive analytics, basically it consists of rules and optimization. Typically, organizations will be able to combine the predictive and prescriptive analytics capability to exploit their respective strengths. So with that, the company can push the limit in terms of greater business impact in the competitive industry. With that, recently, data science and machine learning emerged as one of the important disciplines in the industry, in analytics ecosystem. So with that, I hand over to my colleague, Christine, to walk you through more detail pertaining to all the techniques involved. Christine, please.
Hi. Okay, so in terms of product and pricing decisions, there are several managerial decisions that companies like to make, for example, in the area of products and also in terms of buyers, understanding more about the products and the buyers. For example, whether we should advertise, whether we should change prices, launching a new product, or assess the impact of marketing and communication effectiveness. Specifically, some of the questions that we are interested to look at is what factors or product formulation are important in driving brand choices? What prices shall we charge for different range of products? for the good range, for the better range, and for the best range of products. Which advertising messages and campaigns are effective in deepening engagement with our stakeholders, as well as which customer or stakeholder segments should we target to drive conversion and improve profitability. Okay. There are some emerging trends in products and pricing analytics, for example, in the area of product development as well as go-to-market commercialization. In the area of product development, we see rapid experimentation and simulation in terms of product and process innovation. So in the new product development process, all the way from understanding the new product strategy, evaluating and validating our ideas, screening the ideas, developing and test marketing, and into commercialization of the new products, all these we see rapid experimentation and simulation. In the go-to-market phase, i.e. the commercialization phase, we see the introduction of real-time analytics, dynamic pricing simulation and optimization, as well as utilizing digital and connected products in terms of product innovation. And of course, like what Brandon mentioned, in the area of big data analytics, we see the introduction of more statistical and machine learning techniques and the utilization of deep learning techniques, especially in recent years. Okay, there are two major tools and techniques in product and pricing analytics, namely observational studies as well as experimental design. What is observational studies? In observational studies, researchers are only observers. They measure what people do or say what they will do in a situation not of their making. For example, you may be familiar with just developing surveys or just doing focus groups. We are just observers, like the little kid you see on the left-hand side, just understanding and observing the butterfly in action, but we are not doing anything to influence the situation. So in contrast, when we are conducting experiments, researchers actually control the important variables, or we call them factors, which influence consumer behavior so that we can more precisely observe the cause and the effect. So in a nutshell, in an observational studies, researchers don't assign any factors or choices. They only observe what is already happening. In contrast, an experiment, researchers actually manipulate factors or variables. They create a treatment, what we call a treatment, and compare the responses. Take the cartoon example that you see on the right-hand side, this cartoon character from Sesame Street called Beaker, and the experiment here is to test if he can protect himself using a scarf from electricity. So the doctor standing behind him is trying to, electrocute him with this instrument. So there are two factors here. One is the scarf. Beaker is wearing a scarf. So the factor will be whether he's wearing a scarf or whether he's not wearing a scarf, and the second factor will be the electrocution, whether a high or low dose of electricity can, will electrocute the poor fellow over there. So that is the difference between observational studies and experimental studies, and we'll see how we can implement this in business experiments. In observational studies, these are some of the tools that you may be familiar with. For example, implementing primary and secondary market research. So this could include structured, unstructured data that you see that most of you are familiar with on social media. You start to post different structured and unstructured data, including images, text, and all that. All these are primary and secondary market research, which are part of the observational studies. The second area is knowledge and consumer immersion. For example, you can see the lady looking at the kitchen, understanding how people, navigate their way and observe what they do in their natural environment. So these are observational studies or ethnography. And we can also look at how we can extract value from connected products and services, and as well as real-time analytics using smart sensors. The third area is quantitative surveys, direct questioning, so on and so forth. So comparing data then and now, in the past, data in the 80s and 90s tend to be quite limited. And they are mainly structured data in terms of survey data, transactional or behavioral data. But data now is totally different. It's this whole array of structured and unstructured data that we see, including search, product review, social networking, so on and so forth. Okay, so in terms of observational studies, ethnography is a type of observational research studies which is enabled by offline and online tools. It is a convenient way for participants to share how they can interact with their products and services in their natural environment. So take, for example, when IKEA shoppers navigate their way through the retail environment, we can actually understand what attracts them to certain zones and what makes them stay in a certain area for a longer period of time. So understanding consumers in their natural environment will allow us to develop products and services that will enable them to make use of in their natural environment. So take, for example, the smart tables on the left-hand side. This is an invention by IKEA which would recognize products and meat placed on it. And the smart table can suggest recipes with these ingredients. It can even teach you how to slice and dice more efficiently, offering tips for chopping broccoli and more. Okay, so let's watch a video on ethnography of IKEA shoppers.
Interior designers must be comprehensively equipped to create supportive, responsive environments. From hospitality to workplace and healthcare to retail, the demand for multidisciplinary solutions is formidable. Like William White did in The Social Life of Small Urban Spaces, we observed IKEA shoppers and mapped their meanderings. The biggest secret to IKEA's success is its maze-like spatial organization, designed to obscure a path to the exit. Shoppers meander along a 12-foot wide public street, continually distracted by fully accessorized private rooms to the right and the semi-private salon to the left. IKEA's other secret is the shortcut. We were interested in how many people take the shortcuts and why. The shortcut option allows an out for those who feel a loss of control by being confined to the street, like cutting through an alley. In exercising their freedom of choice and the need to break away from the herd, our study revealed that 40% of IKEA shoppers take the shortcuts, because shortcuts give people a sense of autonomy. People need to make their own rules in how to use space, proving that user autonomy is essential to successful interior design. Another observation that intrigued us was shoppers' interaction with the merchandise. Who samples what, how do they sample, and for how long? People tend to go where other people are. The reason for this is the human act of crowding. We observed that strategically placed product augmented by color, lighting, and pricing attracts the first herd member, and then others follow. Retail strategies designed to attract, engage, and ultimately get shoppers to purchase owe their success to consumer psychology. As the environmental psychologist Paco Underhill says, if we went into the stores only when we needed to buy something, and if once there we bought only what we needed, the economy would collapse. IKEA's environment provides shoppers with just the right sense of belonging, freedom, and safety. We also noticed that verbal engagement varies with gender. Men engage in conversation 52% more than women, while women, consumed by spatial interaction, are seriously focused on shopping. How important and applicable are the lessons of human behavior? The human-centered approach to design places users' needs first, and good design is ultimately judged by how conducive it is to human experience. Incorporating psychological, behavioral, social, and cultural research methods enables designers to identify strategies by which to create a reciprocal relationship between space and its users.
Okay, so having seen the ethnography for IKEA shoppers actually helps us to understand more about the environment in terms of retail. So the next, another type of observational study is called customer journey mapping. Customer journey map is actually a visual representation of a process of where a customer or prospect actually goes through to achieve a goal with the company. So using ethnographic research like you have seen from the IKEA study, we can actually map out what is the customer journey, and it allows the company to get a sense of the customer's motivation, needs, and barriers and pains in its natural environment. So we can collect data from our customers and prospects using ethnography and observational research, talk to our customers and prospects, and then using the information, we review the data sources and come up with a customer journey map. So we can even develop personas and understanding what our target audience really is, what are their typical motivations, barriers, and pains. And these customer personas can be used as profiles based on their demographic, behavioral, and also psychology measures. Okay, an example of an observational study using customer journey mapping is this example from the Shopee UX case study. So the case study here is trying to understand the customer pain points in terms of navigating Shopee's mobile tool. So during the interviews and observational research, a few pain points are being uncovered. For example, the user feels that there's too much information and text on the mobile tool. The user is unaware that there are actually more icons on the home page, and they expect to know more about the trends in their age group and other areas. For example, they expect to be able to sort the search result more efficiently, so on and so forth. So some of these pain points are actually uncovered during the observational studies, which can be used to then improve and develop new online products and the mobile applications more efficiently. Okay, so why do we need experiments? How are experiments different from observational research? So it turns out that experiments allow analysts or business partners to answer business questions related to cause and effect. It is important for the analyst to know whether we have an umbrella problem or rain dance problem. So what is the difference between these two? If what you are interested to know is whether or not you should carry an umbrella, for example, then you have a pure prediction problem. You just want to predict whether it will rain or not. So causal questions, i.e. cause and effect, is of secondary importance to you. And you only need to know whether the probability of rain is high or low, so that you will carry an umbrella. On the other hand, if there's a long drought and you want to end the drought, then prediction is of little value. In this case, you are interested in causal questions, i.e. cause and effect questions will be of primary importance to you. So if you want to induce rainfall, then you need to know what variables that will cause the rain, and you try to manipulate these variables. And that's what experiments are all about, using cause and effect. So how do we conduct experiments? So it turns out that we can actually conduct experiments before the launch of our products as well as after the product launch. So before the product launch, we can use different statistical techniques depending on how many factors or variables that you're interested to test. So for example, if you're only interested, in the simplest case, if you're interested to test just one factor, you can make use of this tool called A/B testing. Basically, if take the example of the Shopee example, if you're trying to compare, say, two landing pages to see which one generate more sales, as you can see from the screen. So A is the first one on the left, B is the second one on the right. So using A/B testing and using a statistical technique called hypothesis testing, we can compare the landing pages to see which one has a higher click-through rate. So that's the first one. But if the techniques, if you have more factors to test, like in the bigger example, there is both the scarf and the electrocution tool. If you have more variables to test, then you can make use of multivariate testing using predictive analytics based on regression methods. These are more advanced techniques involving screening designs, factorial designs, and conjoint analysis that can be used to study multivariate factorial experiments and interactions. Okay, now we'll look at one video on A/B testing.
Hi, and welcome to this quick introduction to A/B testing. So what is A/B testing? At a high level, A/B testing is a statistical way of comparing two or more versions, such as version A or version B, to determine not only which version performs better, but also to understand if a difference between two versions is statistically significant. So why do businesses conduct A/B tests? This is the way businesses are run these days, and they have to take a data-driven approach. A common dilemma that companies face is that they think they understand the customer, but in reality, customers would behave much differently than you would think, consciously or subconsciously. Users don't often even know why they make the choices they make. They just do. But when running an experiment or an A/B test, you might find out otherwise. And the results can often be very humbling. And customers can behave much differently than you would think. So it's best to conduct tests rather than relying on intuition. So let's visualize. For example, in marketing or web design, you might be comparing two different landing pages with each other, or two different newsletters. Let's say you take the layout of the page. You move the content body to the right now versus the left. Or maybe you change the call to action from green to blue. Or your newsletter subject line has the word promotion in version A and the word free in version B. In order for A/B testing to work, you must call out your criteria for success before you begin your test. What is your hypothesis? Or rather, what do you think will happen by changing to version B? Maybe you're hoping to increase conversion rate, or newsletter signups, or increase opens. Call out your criteria for success ahead of time. Also, you will want to make sure that you split your traffic into two. It doesn't have to be 50-50, but you will want to figure out what is the minimum number of people I need to run my A/B test on to achieve statistically significant results. You can do this with multiple versions, such as 2 buttons that are blue and 2 that are orange. 1 blue and 1 orange button say RSVP, and another blue and orange button say sign up. This would be called a multivariate test, or a full factorial test, since you are comparing different factors. So what are some factors we can test on when conducting an A/B test? Changing the layout of the page and shifting where certain items are, such as moving the content body to the right, the navigation to the left, or the call to action near the bottom. You can change the call to action, such as changing the color, or the text, or where the call to action is located on a landing page or email. You can compare 2 different images with each other to see if one has a higher conversion rate or a higher click-through rate. And what about on the back end? Suppose the UX and the UI is the same, but you update your machine learning algorithm to update the recommendations that are shown to people. But what happens if something is broken, or funky, or the data is messy and the quality is off, or there's too much noise? Maybe there's a sampling problem and you don't randomize correctly. It could be a 1 to 2% impact, but you should make sure that your A/B test is being conducted properly first by setting up an AA test. Thanks for watching. Give us a like if you found this useful, or you can check out our other videos at Data Science Dojo Tutorials.
Okay, so you see the example for A/B testing. So if you only have one factor and you're trying to look at different levels, then depending on the number of levels, if you only have 2 levels, then that's A/B testing. But if you have more than 2 levels, then it's A/B-N testing. Okay, so here's an example of more than 2 levels. For example, in the contact lens company, they are interested to test whether different benefits for different usage occasion would actually induce more patients to buy their contact lenses. So the first creative is on advertising contact lens in terms of able to perform in challenging environments, vis-a-vis another creative to look at beauty enhancement as a benefit for contact lens users, vis-a-vis UV protection. So these are actually 3 different benefits. So this is you can consider this as an A, B, C, 3 different types of creative approaches. So this kind of testing is still belonging to the one factor, because one factor can have many levels. So in this case, we have 3 levels, but still belonging to one factor. So we can still use this simple technique of A/B testing or ABN testing to test product concepts offering different benefits for different usage occasion to see which one will be more appealing to our buyers or consumers. But however, if you have more than one factor, then this calls for another technique called multivariate testing. So as the name implies, multivariate means we have more than one factor. So take, for example, if you're interested to test the effect of, say, promotion, message, or price at different levels and how it will impact on your sales uplift, you can actually use multivariate testing. So this is an example where there is a low level and a high level for promotion, messaging, and pricing. We can actually run different treatments of the experimental design. So a negative sign means the level is missing. The positive sign means negative sign means there's a low level. The positive sign means there's a high level. Okay, so we can actually use predictive analytics based on multi-regression techniques to analyze different experimental designs for determining the cause and the effect relationship. So in fact, in this case, the cause will be looking at the impact of promotion, messaging, and price on the effect on sales uplift. If you have even more factors, in this case, on the left-hand side, we have 3 factors. On the right-hand side, if you have more than 3 factors, in this case, like 4, 5, or even 6 factors, this calls for a more advanced technique that will utilize screening experiments that allow you to screen the important factors more efficiently. Okay. So that is for what we've seen is for pre-launch experiments. Now let's move on to post-launch. In the post-launch and in the post-launch setting, our business stakeholders are interested in the following objectives: driving awareness, consideration, and purchase, targeting the right customers through the right channels with the right communication messages. So how can we support our business partners to address these business objectives? Okay, so after the product is launched, the product is out in the marketplace, so we call it go-to-market or in the commercialization stage, we can continue to do post-launch experiments. So for example, if you want to test our communication messages along the key stages of the customer journey, how effective are our various communication messages, we can actually continue to employ experiments. For example, in the first stage is awareness stage and consideration stage. How aware our consumers, our patients, or customers of our new products or our existing products? Would they consider our products? So we can actually test different creatives, for example, the one on the left versus the one on the right, using different narratives, different benefits. We can, based on the observational research or even the experiments that we conducted during the pre-launch phase, we can test it and see which one is more effective. Okay, so the third phase of the customer journey is purchase. So after they are aware and they are considering to buy your products, they may eventually purchase and advocate for your products. So at this stage, we may want to make our products more visible in the eyes of our consumers, our patients. So if the business is selling spectacles, they may want to consider testing maybe different approaches at point of sale. For example, using a recommender system that you see on the panel on the bottom. So looking at whether with or without this recommender system panel, would it induce more sales or not? Okay, so that is on targeting, using experiments to target the right customers. How about the right messages? We can also use experiments in the online space to test message effectiveness. For example, version A and version B. So on the top, you can see whether with and without, for example, incentive, for example, enjoy a $10 off your first purchase. Which one will be more effective? On the top left-hand corner is the version on the left, or the version on the right, would it be more attractive to the customers? Okay, so the one at the bottom basically is looking at for a mobile landing page for a storage company, whether using different approaches, for example, be able to detect the current location, would it have more click-throughs, things like that. Okay, so other messaging approaches, for example, if you are selling clothes, which would be more appealing for your customers to click through? Will it be showing a full length of the person, or is it just having a crop shirt image? Okay, and then on the right-hand side, you can also test whether with and without a video icon link, which one will be more effective in driving click-through rates. So any guesses for any of these approaches? So it turns out that for the first one, in terms of email sign-ups, giving $10 off incentive can actually help to stimulate the first purchase. And at the bottom, having this this button that able to identify the current location will enable more click-through using the zip search. And of course, for the skirt image, the crop one is much better. And it turns out that for the video icon, there's not much difference. So these experiments can be used to test very efficiently on the online space. Okay, so having looked at the right customers, the right channels, we move on, or right messages, we move on to the right channels. We can also use experiments to test whether in the online space, whether messaging through coming from emails or the internet search is more effective in driving click-through, or we can test whether sales calls using audio sales calls, that means telesales, or using video sales is more effective in driving sales conversion. Okay, so in a nutshell, businesses need to balance both long-term and short-term goals, and we can use experimentation to actually test and measure these two types of marketing in different ways. So in the short term, will our messaging and advertising efforts have any sales uplift effect? And in the long run, will our benefits and messaging be able to drive long-term awareness and sales for the organization? Okay, so that's on experimentation and predictive analytics. Now we will just move on into the next area in terms of developments in statistical machine learning and deep learning. So as most of you may be aware, you may have heard of this term called machine learning, but perhaps statistical learning may not be so familiar to you. Machine learning arises as a field of artificial intelligence, whereas statistical learning, which is a relatively new term, arose as a subfield of statistics. There's much overlap though. Both fields focus on both supervised and unsupervised learning problems, which I'll elaborate later. So machine learning has a greater emphasis on large-scale applications and prediction accuracy, while statistical learning focuses more on models, interpretability, as well as precision and uncertainty. So there is some difference, but there's also some great deal of cross-fertilization. Okay, so both statistical and machine learning involve both structured and unstructured data. So what is structured data? Structured data comprise of clearly defined data types with patterns that make them easily searchable, for example, in a database format, quantitative information on, say, demographics, as well as behavioral information. On the other hand, unstructured data is comprised of data that is usually not so easily searchable, including formats like audio, video, social media posting, and text. Okay, so what is supervised versus unsupervised learning? So supervised learning means that there is an outcome measurement Y. Typically, we call it a dependent variable or a response or a target, versus a set of predictors. We call it features or X variables, measured based on a set of samples. Okay, in supervised learning, we have two types of problem. One is a regression problem, where your outcome variable Y is quantitative. For example, we are interested to predict sales, vis-a-vis a classification problem, where the dependent variable Y takes on values in a finite, unordered set. For example, in a classification problem, we may be interested to predict whether the customer respond or not respond to our campaign, whether the customer is high, medium, or low risk. So it can be binary class, it can be multiple classes in a classification problem. But in a nutshell, supervised learning has an outcome variable Y that we're interested to target. Examples are prediction and forecasting techniques that you can see on the right-hand side. On the other hand, unsupervised learning, there's no outcome variable. It's just a set of predictors, or we call it features, measured on a set of samples. And objective is a little bit fuzzy. We are more interested to just find features that behave similarly. So let the data speak, and usually it's useful for as a pre-processing step for supervised learning. Some examples of unsupervised learning include segmentation and association techniques that you see on the right-hand side. Okay, so how is structured and unstructured data applied in terms of product and pricing analytics? So some examples include identifying the effects of demographic and marketing data on an insurance policy product purchase. So we can predict a product purchase using demographic and marketing data. We can predict housing prices based on social demographic and geospatial information. Or we can look at the relationship between marketing promotion and the store sales, for example. So you can see the pattern of these three examples is we are looking at a set of, say a set of predictor variables, we call it X, onto an outcome variable Y. Can be predicting prices, predicting product purchase, and also promotion. So the two examples at the bottom, you can see in terms of housing, prices, promotion, it can be a linear relationship or it can be a non-linear relationship. So this call for different approaches, and that's how statistical and machine learning techniques can come in to help us decide what is the pattern behind all these various business scenarios. In an unstructured, on the other hand, in terms of unstructured data domain, for example, we have images, text, speech, and voice data. There are some examples. For example, we're interested to customize, say, email detection spam system based on frequently occurring words or features. Or we may want to predict user interaction and engagement on social media based on image and facial recognition. Or you may be interested to predict positive and negative sentiments based on attributes of internet movie ratings. So what is the commonality among all these three examples? We are making use of unstructured information, be it image, text, or words, so to speak. So at the bottom, you can see that we are trying to find what is the frequently occurring words in order to predict whether the email is a spam or non-spam. And we can make use of sentiments on the social media, say attributes of internet movie ratings to predict positive, whether it's a positive or it's a negative sentiments. So all these are in the unstructured data domain. Okay, so moving on, so if we have such a wide array of statistical and machine learning techniques, so how do we choose the best model? So in general, there are three broad approaches. So the first one is subset selection. So just like what you saw from the previous slide on the housing prices promotion, we will try to develop models, and these models can be a linear relationship, can be a non-linear relationship that will predict housing price, for example. So we use a subset of P predictors that we believe to be related to the response Y, for example, predicting housing prices. Then we fit a model and we decide whether is it a linear or non-linear relationship in driving housing prices. The second method is dimension reduction. So if you have many predictors, in this case P predictors, you may want to then project these P predictors into a smaller m-dimensional subspace. So this is achieved by computing m different linear combinations or projections of that variables. And then these smaller m projections are used as predictors to fit a model by least squares. Okay, last but not least, there's shrinkage method used for large sparse data set. And we can use, let's say we can fit a model involving P predictors, and then these coefficients are then shrunken down, which will help to reduce their variance and also help us to perform variable selection. So there are a variety of statistical and machine learning techniques that can be used to help us select which is the best model. Okay, so as an example, in terms of model selection, linear and non-linear models, if in this example we are interested to predict income based on social demographic survey data, example age, education, so on and so forth. So we may fit either a linear model on the left or a non-linear model on the right, okay, depending on which one has a better model fit. In general, some statistical and machine learning techniques tend to be more flexible, and some tend to be less flexible. So the more flexible machine learning or statistical learning techniques will help you to fit a more non-linear model. So as you can see from the chart on the right-hand side, on the x-axis, for those techniques that are tend towards the right, they tend to be algorithms that allow us to fit a more flexible model, whereas algorithms on the left will fit a less flexible model. So for example, a technique called multiple linear regression or least squares typically fit a less flexible model, whereas machine learning techniques like support vector machine, deep learning techniques tend to fit a more flexible model. But however, these approaches have its trade-off. The more flexible model tend to have less interpretability. So it depends on our business objective, whether we are interested more in prediction or we are more interested in understanding what are the drivers and interpretability of the model. Another example is on dimension reduction. So say for example, you're interested to predict housing prices, for example, and that is your response, and you have a list of predictor variables X, and when you are confronted with too many predictor variable X, you need a way to efficiently reduce this dimension. For example, more than 100, maybe more than 80, 90, reduced down to about maybe less than 10 variables, for example. So dimension reduction technique is the way for us to reduce high dimension to lower dimension and efficiently uncover patterns behind such data sets. The third method is called shrinkage method. So shrinkage method is another way for us to efficiently uncover trends behind the data by shrinking the coefficients on high dimensional data set. So if you are interested to predict, in this example, assessing credit risk based on demographic and behavioral information, we can use some shrinkage methods to reduce high dimensional data sets into a smaller coefficients, which will allow us to then better predict credit risk and model fit more accurately. Okay, so last but not least, there's this area of, in recent years, big data has been developing quite recently, especially in the last 10 years. Big data vary in shape, and hence they call for different approaches. So big data can come in different shapes and sizes, one of which is wide data. So wide data means you have thousands, millions of variables, especially in today's environment with social media and the World Wide Web. So, but in this case of wide data, we only have maybe a few hundreds of samples. So depending on what kind of big data you have, it calls for different approaches. So for wide data, typically some approaches may be more efficient as compared to tall data. Tall data is the reverse, where we have tens and hundreds of variables, and however, we have thousands and millions of samples. So in this case, we may also want to use different algorithms to solve such problem set. An example is a search term. So let's say if we have, if we're interested to understand what people are searching for and what kind of search terms will be more efficient to drive click-through, this can belong to the white data kind of business scenario. If you have many columns of text, but maybe you may only have maybe a few hundreds of samples, for example. Of course, last but not least is tall and wide data. So meaning you have thousands and millions of variables, thousands to millions of variables. So in this case, we will need to do more efficient ways, including maybe subsetting the variables or subsetting the samples. Okay, so I'll just wrap up with a few examples in the big data learning problems. So one example is web page browsing using models on large sparse web page session. So for example, if we are interested to find whether families or individuals, what kind of web pages they are interested in browsing. So web pages, there will be many features which are web page indicators and descriptors. So in this example, 7 million features of session information, and we have and this 1.1 million features could be screened down to probably a smaller number of subsets, and we could fit the models. Okay, so in this example, the richest model had about like 42,000 variables, and having a good fit as well. Another example is online shopping using statistical machine learning on large sparse data. So a marketing analyst may be interested to understand people's online shopping behavior. We can treat this as features all of the search terms that is entered by the users in the search engine. So this is sometimes known as a bag of words model, and we can look at based on the search term, okay, and the web page about to be served, what is the probability that each of these 30 candidate ads on the right-hand side will be clicked if it's placed on the right-hand panel. So these are examples of big data learning, including dynamic pricing using advanced analytics in the B2B space. So it's not just confined to the business to consumer space. We can also apply statistical machine learning techniques in the B2B space. Last but not least, big data is also, neural networks, in this case, rebounded around 2010 with big success in image classification. So we see deep learning approaches used in image recognition, which can also be applied in the social media context to analyze a large database of labeled images, and then using a technique, a special family called convolutionary neural networks has evolved for classifying images on a large range of problems. And in addition to images, we can also look at data sources which are sequential in nature, which call for special treatment for predicting, for building predictive models. For example, documents such as book reviews, movie reviews. We can use machine learning, deep learning approaches, for example, recurrent neural networks for classification, sentiment analysis, and language translation. I'll now hand over to Brendan, who will walk you through the other techniques for product and pricing analytics.
Okay, thanks, Christine. Let's move on to the optimization aspect for this course. So what happens that in this case, I would like to deep dive into decision science for product and pricing analytics, mainly for optimization purposes using mathematical, heuristic, or AI techniques in that sense. Now, in terms of optimization, in fact, in the industry, we're looking at the different methods. For example, simplex method, gradient-based optimization, evolutionary algorithm. Now, these are typically to handle a lot of common business problems from linear programming, non-linear programming, integer programming, all the way to Go programming, right? So it is part and parcel of the optimization in a typical organization. Now, if you move on to see this example, it is a very famous business problem to be solved by a lot of organizations. It is application of optimization using genetic algorithm to solve traveling salesman problem. Now, in this case, we are referring to routing optimization. Basically, we try to find the fastest travel time, cheapest travel cost, as well as shortest travel distance. So these are three key criteria. In fact, all of us making use of Google as well. By default, Google are making use of fastest travel time, all right, unless we key in additional parameters, for example, to avoid toll, right? So you will avoid the expressway, go through the major arteries in Singapore transport network. right? So for those working on the transportation, traffic management, shipment, particularly in logistics industry, these are one of the very essential techniques to be applied accordingly. Next is more into the another paradigm. Now we notice that some cases, we notice that prediction and forecasting may not give a best solution out of it. That's why we need to move on to another paradigm, more for scenario planning, modeling, and analysis. What happens in this case, if you're looking at the entire analytics ecosystem, as mentioned earlier on, prediction and forecasting mainly to give us choice-based strategy, right? You're given a analytics insights pertaining to what decision to be taken. On the other hand, scenarios for us to really come up with option-based strategies. Now, what happens so? Because if you're looking at one of the very prominent problem statement here, pre-COVID, during COVID-19 and post-COVID-19, obviously there's a lot of differences to be applied accordingly. Now, based on the data collected over the last 2 years, due to abnormality, the data may not be able to tell the truth or not accurate enough to reflect the actual occurrences in the past 2 years. That's why, in this case, during the pandemic recovery, we shouldn't make any prediction or choices. Rather, business are move on to another paradigm, which is to create options by using scenario planning. Now, for those make use of what if analysis in Excel, these are similar scenario in that sense, right? So this is one of the another paradigm in terms of optimization. Let's move on to another aspect of it. Product is being managed in terms of inventory. That's why in this case, inventory planning and simulation again is very important. Now, why we need to ensure the inventory management and optimization techniques to be conducted because of some issue due to pricing and product. You're looking at the relationship between sales and profits in terms of product life cycle. So you can see that these are from economic point of view, right? In terms of revenue generation corresponding to the sales, and obviously all this affected by the product and pricing. So with that, there are some very essential techniques to be implemented in terms of inventory optimization, particularly from deciding the optimal quantity, which is economic batch quantity, economic order quantity. Now we are referring to how many should we purchase in one go in order to request for further discounted price, right, and etc. Next, we are answering the question of when should we kick off the purchase cycle. Procurement process may take longer during the COVID due to longer lead time. Now it's referring to reordering level or reorder point. There are some cases we need to further classify our inventory accordingly in terms of their usage, in terms of the value, and etc. It can be achieved via ABC analysis. ABC analysis is following the Pareto chart style based on 80-20 rules. Next is the service level models. If we not be able to cater the needs for the customer order fulfillment, there is a huge opportunity lost from the dollar and cent perspective. That's why we would handle accordingly, particularly the lead time, which can see they anticipate much longer or uncertainty in terms of lead time during the COVID-19 period for supply and demand ecosystem. Last but not least is a safety stock. How much should we reserve or increase our buffer to anticipate any unforeseen circumstances in terms of supply chain? This will avoid any downstream impact, be it in our service industry, product, or even manufacturing industry as well. So the next one, we notice that there are cases in terms of the supply and demand. Not all the situations are deterministic, meaning there is a lot of factors involved in, by and large, in terms of uncertainties, and we refer this as non-deterministic or stochastic. Now, from stochastic perspective, without a choice, we have to move on to another way of handling the analytics, which is Monte Carlo simulation. So we can see from here, in terms of Monte Carlo simulation, we try to make use of the random number to model after certain business behavior and simulate it. Can be done via tools, package, or even programming languages. Right? So this is meant by Monte Carlo simulation, to simulate any unforeseen circumstances or things are mega project where we can't really simplify using our normal calculation. So this is an example from any logic pertaining to the demand-driven supply chain, how the inventory are being shipped from factory to distributor, wholesaler, and finally to retailer as a last stop, last mile delivery before reach out to the intended target customers. The next item for optimization is locational information. We notice that location information for customer can be quite important for us to do a much more geo-targeted marketing. In short, geo-marketing. As per now, in the past, until now, a lot of cases where we pretty much focus on static data, meant for statistical modeling. We may even focus on timestamp, time series data for forecasting. A lot of cases where we just simply ignore this partial aspect of it, which is locational information. In fact, locational information is very powerful for us to answer the where question. So with that situation here, this is one example where how we can make use of checking locational information by a customer and identify the best option for them. So you can see in this case, we can track geo-tracking and geo-tracing of particular customers, and from there we can identify the point of interest. We can do a buffering, geo-targeting, geo-fencing to ensure that we do a much more appropriate geo-marketing effort, where all the effort won't be wasted because it's very personalized, individualized pertaining to the location, where they go about, and etc. Where location they visited, what is the interest. So with that situation here, ladies and gentlemen, in this case, we're looking at the sensing level, how the data being collected from the mobile application, mobile app, doing check-in, check-out. Sense making level, how we make use of the locational information, data enrich locational information to make decision out of it. Obviously, last but not least, this will fit to the decision maker for decision making level. So it's transiting from sensing level to sense making level all the way to decision making level in this context. The next one is retail analytics as well. Now, we notice that in the latest technology, we're always referring to real-time streaming analytics, right? Coupled together with sensor technology like IoT, coupled together with streaming analytics, edge computing, and etc. Now, all this put together as a solutioning to improve the in-store operational excellence. Now, in overall, it will improve the commercial excellence by a typical organization. So next, we look at the video pertaining to one of the case study.
In today's highly competitive marketplace, grocery retailers strive to create a seamless shopping experience that drives sales and builds loyalty with their customers. IoT-connected devices such as beacons, video cameras, digital signage, and smart shelves provide access to huge amounts of new data on customer activity and present more opportunities for sophisticated insights and immersive customer engagement. IoT data is used to track the effectiveness of store layouts, exposure to promotions, product interactions, and use of digital kiosks and mobile apps. This data is analyzed in real time to create deep insights into customer preferences and path to purchase. Digital Assistance allows customers to find the items on their list, interest them in new products, and select promotions to save money. And for marketers, identifying customer desire, delivering curated content to upsell and cross-sell, and measuring the success of promotions has never been simpler and more accurate. IoT provides service-level metrics and enables store managers to eliminate long queues, schedule staff efficiently through cognitive intelligence, and make sure customer expectations are being met at every service point in the store. IoT, revolutionizing the retail experience.
Okay, so the video will be able to recap what we've done in terms of the locational analytics, the real-time streaming analytics, and etc. to improve the overall commercial excellence. The next one as well is very important, which is capacity analytics. Now, due to the shortages of manpower, resource, particularly human resources, is very important to be utilized and optimized accordingly. This to avoid any shortages of the resources. Now, in this case, the techniques we try to cover in this case is learning curve. This optimization techniques, or in some industry we referring this as experience curves. What happens is that we try to ensure that the people are getting better when they're repeating the task again and again. With that, we need able to have lesser resources to channel to one of the particular tasks in your daily business operations. So in this case, we'll be able to optimize our resources, which means we'll be able to avoid overestimate of the labor needs, so that you will reduce the wastage of the human resources. On the other hand, we also be able to, with the right amount of staff strength, we'll be able to avoid the underestimate of material needs, meaning that we can avoid the shortages of material products and etc. This to avoid the shortages in terms of product, service in a typical organization, more so for manufacturing industry, retail, and etc. With retail, sales, and etc., we also move on to day-to-day ops, which is operational analytics. Now, in this case, in the typical world, in physical store, for example, you're referring to physical footfall, or in digital space, online, e-commerce website, we're referring to digital footprint. And these are foot traffic analytics we try to address because of demand planning and management. And one of the key techniques here is queuing model. So with that situation here, as we can see from here, very close to our heart is the happening during COVID, where everyone rushed to the clinic to get MC, or at the vaccination center, everyone queue up for the first jab, second jab, and booster jab, for example. Now with this situation here, the in-charge operator or the clinic owner will be able to deploy the right number of staff, medical doctors, for each particular duty, so that you'll be able to handle the queue. Right, so in incoming traffic, which is the patient or citizen, go for vaccination, is meant for incoming traffic, whereas the counter available is referring to the server. The other example is that how many beds to be prepared for the normal bed or meant for ICU due to surging number of COVID in the past 2 years, and etc. So with the situation here, queuing model can be used to further optimize the operational aspect of the organization. With that, overall, we'll be able to improve the commercial excellence in that sense. So in the end, what happens that what Christine and myself, we cover those important techniques, content and topics pertaining product and pricing analytics, as well as analytics for commercial excellence, respectively 4 days for each course in this case. So you're strongly encouraged to visit our website pertaining to the detailed information for these 2 courses. More importantly, the upcoming class for the first product and pricing analytics course is from 6th of June to 9th of June, whereas the subsequent course, analytics for commercial excellence, will be on 1st of November to 4th of November. Do visit our website accordingly pertaining to all the information detail published at our website. So in a nutshell, This shows the overall summary of all the techniques, subject matters, topics to be covered in these 2 courses throughout the 8 days content. In terms of the lecturers, besides myself and Christine, we do have Dr. Tan as well join us to cover the deep learning. He's from artificial intelligence practice because deep learning is quite specialized in that sense. So we engage him to as well to cover the 8 days course in this case. Now, before we move on to this, maybe I have some clarification. Christine, you mentioned a lot of the advanced analytics in your topics as well. So what are the basic prerequisites that the participant or the potential candidate need to in order to handle the subject in this case?
Okay, so just now Brandon and I covered quite a number of techniques. Maybe it seems like quite too many for you to remember. But
Yes.
basically you can think of it in terms of, like I covered mainly the predictive techniques from experimental design, statistical machine learning, and he covered more of the optimization space. But this does not mean that you need all these deep knowledge before you come to this program. So through these courses, we will be able to teach you all these different techniques in the predictive and in the optimization space. However, you do need some basic fundamental knowledge of statistics and preferably predictive analytics, and if possible, some basic business domain knowledge in in product and pricing analytics. So we do not need you to have very advanced statistical knowledge, just foundational knowledge will do. Yeah. So maybe Brendan, how about the software requirements for this course? Would you be able to elaborate and let our
Okay, sure. So for all the courses, for information, ladies and gentlemen, in AUS ISS, we are practice-oriented training. We adopted this training style, teaching pedagogy as well. So what happens in this case, all the courses, all the topics to be covered with practical workshop, meaning that you need to do some hands-on work pertaining to the topics covered for the particular courses and topics. Now what happens that in this case, we also adopting tools agnostic, meaning that we don't specifically train you for a particular software, right? It really depends on your opportunity to work in the industry, where what are the license, what commercial license available, what are the platform they're adopting in the particular organization. So with that sense, for example, typically we make use for optimization, for example, typically I make use of Excel and Power BI. It's a tool based, immediately you can see the output and be able to appreciate further in terms of the concept covered in the lecture all the way to the workshop. After that, the additional workshop will be in terms of the programming style, using R programming or Python programming, that you'll be able to relate back to what are the actual implementation in the industry as well. Yeah, so it's from tools all the way to the programming method. How about your topics in terms of the workshop?
Okay, so do take note that the topics covered in this course will be focusing primarily on the predictive and the prescriptive or optimization techniques. However, we do need you to be able to use computer software like basic Excel, which most of the workshop will be using. And perhaps some just basic knowledge of, say, R programming software will do. But however, if you are a little bit concerned about programming, language will guide you through during the workshop. So don't worry too much about it. So basically, we are more focusing on the predictive and the prescriptive techniques, and software is just an enabler, and we will guide you through during the workshop. Yep. So with that, maybe we can open the floor to questions and answers for the rest of this session. If you have any questions, feel free to post into the chat, or you can unmute yourself and just feel free to ask us questions. Anyone wants to start?
No question. Okay, while waiting for the time, waiting for the rest to key in your question in chat box, for example, right? So maybe I have one more additional information pertaining to the optimization. I pretty much covered the prescriptive analytics. So in typical organization, for example, supply chain or logistic for demand-driven supply, there are cases where due to the complexity, uncertainty, and obviously multidisciplinary involvement because of the cut across business domain analytics per se, there are cases where all organizations skip the predictive analytics, they move on prescriptive analytics straight away because they base on what they have currently at that juncture to make a decision so that they can move on to the next level. More in terms of optimization, all the resources available to them. So in that situation, they'll be able to improve the overall performance from commercial excellence perspective. Yeah, so these are more for the prescriptive analytics meant for decision-making process.
Okay, so we'll just wait a while. Feel free to just post your questions into the chat. Okay, there's a question on the difference between predictive and prescriptive analytics. So maybe I'll just start first and then Brendan can add on. Okay, so as you saw earlier on when we first introduced some predictive analytics technique, for example, statistical and machine learning, as well as experimental design for predictive analytics. Those are more statistical tools that are used for prediction, as well as in the case of experimental design, trying to understand the cause and effect relationship between the predictor variables and the outcome variables. But however, predictive analytics is only able to look at what is the cause and effect and what is the impact of certain drivers on the outcome variable of interest. But prescriptive analytics go beyond that, which I think Brendan can help us to elaborate further.
Okay, sure. So in terms of prescriptive analytics, it's just terms in terms of the analytics maturity model, right? From descriptive, diagnostic, predictive, all the way to prescriptive analytics, right? The name obviously can be seen as a prescribed, right? Prescription, for example. What are the recommended, suggested, actionable insights for the human to take? So in the past, for example, we do have some situation where in terms of prescription, people are quite familiar with rules. Right, so for example, business rules always apply in the business application, decision support system, business information system, or more so in the past in terms of expert systems. How we model a system to behave or mimic the behavior of human expert in giving a suggestion to the user in that sense. So in nutshell, prescriptive analytics more for the suggesting the actionable insights for us to take. However, for example, in medical environment, due to life-threatening environment, right, we still need to have medical doctor as the real person to evaluate the suggested output from the system in order for them to take the real action. Now, this is meant for the actionable item. There are cases where, in this case, all the techniques covered mainly are from operational research, expert systems, or more for decision rules, and etc. So in other words, one is more for future-looking trend patterns, the other one is to take action according to what's going to happen next in that situation. Hopefully we answer that particular question.
Okay, so in the analytics ladder, which Brendan showed in the beginning of this webinar, the journey actually starts from descriptive, which is answering the what, to the diagnostic, which is answering the why, to predictive, which is looking at what is the impact of certain decisions, and finally to the prescriptive analytics, which is taking decisions based on models. So this is actually a journey, analytics journey, and this particular the two courses that we have mentioned just now focus more on the higher order level skills, which is the predictive and the prescriptive analytics skills. So you help you build, to see the roadmap and the journey in this analytics, intersection and interrelationship. Okay, so the word product and pricing analytics doesn't mean that it's only focused on private sector or commercial kind of decisions. In fact, the techniques and tools can be used in public sector as well, if some of you are working in the public sector, because these tools and techniques, experimental design, statistical and machine learning, and optimization techniques can also be applied in terms of policy formulation, policy communication, as well as engagement with the stakeholders from the public policy perspective. Okay, so we do encourage participants from the private sector as well as the public sector, if you're interested, to come and join us in the first run of our product and pricing analytics in June. Okay, there's a question: how do you readily procure the data or market information from the websites without scraping or getting the consent of this information? Okay, so maybe I will start first, and then Brendan can add on later. Okay, most of the information is true that there's PDPA and things like that. There are some of these issues of concern, but increasingly we also see digital tools being employed in many organizations. Like Google Analytics is used widely in organizations to scrape digital information, and this can be potentially powerful in terms of understanding website behavior, website usage, which traditionally from survey data we would not be able to get it. Yeah. So of course there is limitations in terms of getting own organizational information. You may not be able to see the whole picture beyond what you can readily access from your own digital tools. But of course, within the limitations, we do see a lot of students who have gone through our internship, harnessing digital information, which is accessible from their internal organizations, making use of predictive and prescriptive analytics tools to also come up with meaningful and actionable insights. Yeah, maybe Brendan, you want to add on to this?
I think the more important is that no data, no this project, right? So what happens is that the company must start somewhere, someplace, sometime to ensure they started to get started with the data journey, which is the data collection, data integration, all the way to data analytics, right? So in that sense, obviously, if a company are having a huge data repository from traditional database or LTP, all the way to the analytical, which is in the past, data warehousing, data mart, and etc., to currently data lake, for example, all the way to the big data ecosystem, like house, even transform the paradigm to data mesh, right? So all these are the steps the organization has to go through. It really depends on to what extent the company willing to push the limit further to improve the analytics capability in the organization, right? So one of the techniques we see a lot of cases where due to lacking of data and companies starting collecting data, they can make use of open source data to build a proof of concept, right, as a model in the initial stage. After that, they can be able to substitute with the actual data collected or when they started the data journey, right? So I think this is some of the key issue in terms of data. Yeah.
Okay, so those techniques that we have covered briefly, the predictive and the prescriptive techniques, they are more often or not applied on even small data sets. I mean, small and medium data sets within the organization. So big data is only started in recent years, and if organization is able to access to big data, you can also apply predictive and prescriptive techniques on them. But in most of the examples that we see from internships and also real world examples, in fact, most of these techniques are employed in what we call small data or even medium-sized data, and actionable insights can be drawn from these applications. So, like what I mentioned, there's this wide data or long data. So different types of data need not be big. It can be like whatever that you have access to you within your organization and whatever that helps to meet the business objectives and
Yep.
needs.
I think maybe just add on as well in terms of data. For example, time series is not so data hungry model, right? It may require last 2 years. Recency played an important part in time series forecasting. But deep learning, on the other hand, is way too powerful, but it requires a lot of data to train so that it be able to improve the accuracy level as well. So with that, all cases were due to the data constraint, data governance, data privacy issue. Some of the companies are moved on to synthetic data, right? How to generate and simulate the data, so meant for initial training of the model, right? Then subsequently you'll be able to behave accordingly by receiving the actual data as an input to the model, right? On the other hand, there are also cases we're talking about what Christine mentioned just now. We're also talking about the doesn't mean every solution requires big data ecosystem in that sense. In fact, big data, if high volume, low values, in fact, something is not applicable or not practical at all, right? So it's high volume, which means you're trying to find the needle in the ocean, right? Because high volume, the value is very small. In fact, you want to is thick data, white data, small data but meaningful information. Now, all these are maybe is beyond the scope for this, but it's fundamental. Actually, the question is very good because talking about the fundamental problem which lay out, which is the foundation, data requirement before you can proceed with any analytics project.
Yeah. So during the course, we will also explain like what are some of the techniques that's more useful for looking at maybe smaller data sets versus bigger data sets. So for bigger data sets, there will be a small segment on deep learning. But however, most organizations in fact are still managing small and medium data sets, and this we will also showcase some useful tools and techniques that can be used for analyzing organizational data sets. Okay, there's one more question on the more interesting data out there are what our own organization don't have. That's the question. Understand your point about possibly tapping on Google Analytics. Yeah, that's right. So most of the time, within our organization, we probably only have access to what we are able to, harness and able to analyze. Yep. So I guess the journey is still out there to look at greater data collaboration across agencies. In fact, I think public sector is taking that first step to look at how, organizations can share and collaborate in terms of data sets. So thanks, Jacqueline, for asking that question about the interesting data out there are normally what our organization don't have. Brandon, do you have anything to add on?
Is it different to public sector or private sector?
Oh, okay. So,
Yeah,
Jacqueline,
so-
your question, is it more pertaining to, are you in the public sector or you're more in the private sector? So,
No, but the issue is that nowadays due to the data governance, they move on to analytics governance, data analytics, and now the recent one is AI governance, because you can see that more and more data science are tagged along with the AI techniques to improve the analytics output. Right, so we have to adhere to all these compliance from the governance perspective as well. Obviously, there's one publication by Gartner referring to we have to toggle the mindset. We have to share the data, unless otherwise. Right, currently in the industry, we always are really secure our own data as asset to individual silo organization or silo departmental asset. Where you don't share across, you don't see the whole picture in that sense, right? So data sharing, obviously, it will open up the issue with privacy, compliance, and etc. But in order to really make full use of data available in internal, external, across the agency or subsidiary, and etc., I think it's one of the way to go about. That's why recent years we're talking about the data mesh, for example, how we can do a more to domain-driven, right? Data as a service, data as a product. No longer keep the data as an asset within your organization, that it may become obsolete very, very soon if not being utilized to the certain extent. Yeah.
okay, there's another. Okay, so to conclude Jacqueline's opinion. Jacqueline says she's interested in both private, public, and even regional data. So yeah, I guess we are always hungry for data. And there's another question on how about competitor data? So maybe I'll start first and Brenda can add on later. So competitor data-wise, yeah, is always another area that we are interested in. Okay, so actually there are the 3 C's of data, 3 C's. The first C is the customer data. The second C is the competitor data. And guess what is the third C? The third C is the company's data, right? So the competitor data-wise is normally it's quite limited, but traditionally we have been using various approaches. Like just in the beginning, I was talking about observational research. In fact, observational research is where we get most competitor information. You can observe, you can go and do ethnographic study and go into the homes of your patients and their customers to look at what kind of products they are using. So that's observational data. You can even conduct your own focus groups, surveys, to analyze more insights about your products and your competitor products. Of course, nowadays with big data and all that, I think Google is able to look at things like, for example, Google Trends, able to look at what are the most popular being search terms that are used out there to analyze what are the most popular products and services as well. Yeah. So competitor products basically can make use of from both smaller data sets from both survey data, or you can look at maybe the Google domain where they have tools like Google Trends that will help you look at some of these market insights. Brendan, you want to add on to how we can find out more about competitor data?
Typically, if you look at the financial, for example, right? For example, you're talking about we create a dashboard to compare the competitors with your inter-organizational performance from financial perspective. People looking at the published annual report. If it is a public listed company, right? So these are although it is superficial, but I think it's good enough to look at the strategic level of planning, right? In terms of a competitive advantage in the marketplace versus the very detailed level. Because other cases where we look at the competitors, it's more at the strategic and most or even tactical level, but not at the operational level, right? Because day-to-day ops, we're looking at very detailed micro information, but yet that is not the purpose for us to compare among the competitors in that sense.
To add on competitor data, we can also collect competitor data based on experimental design methods. So for example, we can do an experiment, simulate your own products versus your competitor products and see which one has a better uptake, or it can be done efficiently either online or offline. In the online space, can test different combination of factors, levels, and product combinations, and see which one has a higher click-through rate. Is it yours versus your competitor? So, I mean, in today's world, that can be a more efficient way to gather information from competitors as compared to the old days where we could only rely on offline tools like research and surveys to get information on the competitors. Okay, so there's one question on whether is it possible to have a copy of the presentation slides. Brendan, you want to weigh in on that?
Oh, the slides?
Yeah, the slides.
Yeah, okay, we will discuss with colleagues and respond accordingly.
We'll probably we'll probably compile the information and then see whether we can get back to you on the slides.
Yeah, sure.
Okay, so any other questions? We do have about 5 minutes left. If you have any questions to ask us, we will just wrap up with the last slide on the causes, just for your information again. Okay, here, that's right. So the upcoming class in June, early June, 6 to 9 of June. So this is a public class on product and pricing analytics. So do join us if you are interested. Yep. And after this event, we do have a survey, and please feel free to give us your feedback as well.
After this.
Yes.
Do visit our website pertaining to all the information, prerequisite, the key takeaways, and the key topics to be covered in these 2 calls accordingly. I think with that, we can move on to the survey. So we appreciate your...
There's one question from... Okay, sorry, Brendan. One more question from Jacqueline. how much is theory versus hands-on? Okay, actually it is, most of our courses are pretty much balanced. So, but we do give you the foundation in terms of the theory, and it's well balanced with a lot of hands-on exercise, as we mentioned earlier, either Excel and or R. So we will give you exercises in different software so that you are able to get exposure.
Yeah, sure.
You want to add on?
But for some of the topics, because it is very heavy due to advanced analytic techniques we covered in these two courses, and on top of it required some domain knowledge. For example, econometrics, supply demand, right? We're talking about the supply chain, inventory, optimization, business operations, and etc. So sometimes we take slightly longer for our discussion, lecture slides, for example. So without a choice, sometimes we may not have time for you to really do your worksheet or work
During class
yeah, during class itself. So what we do is, as a lecturer, we just go through as a demonstration. So you have the visualization in mind what you need to achieve in the end of the workshop from Excel perspective, right? So after that, after you finish your Excel, obviously you will going to receive additional slides, additional workshop pertaining to R or Python, right? This is again is supplementary to improve your technical skill from that point of view, right? So I would say that maybe ideally it's 50-50 because practice-oriented training, but sometimes without a choice you require more time for discussion. We appreciate the face-to-face contact hours, right? So after the demonstration, you may bring home our workshop in that sense.
Yeah, that's right. So we do have, if there's not enough time, we do let you bring back the worksheets and also the workshop materials. And you can go through at home, and any questions you can just email us and then clarify your doubts if any. But just to clarify, with this course, just need foundational knowledge of statistics and maybe some basic knowledge of predictive analytics. So you are not required to know those advanced theories and techniques that we cover during the 1 hour webinar. Those are what we will be covering, that we will be teaching you during the course itself. So as long as you have basic knowledge and business marketing and we're familiar with Excel, I think that's good enough, and some foundational knowledge of statistics and also predictive analytics.
Yeah. Maybe to add on, for those who are interested to sign up for these courses, you may want to recall or do your self-preparation by going through your mathematics you've done in the past, particularly statistics and operational research. And also, you email to pick up R programming, for example, right? All these are very essential skill sets for a typical data scientist, data analyst.
Okay.
Yeah.
So, okay, one last question from Jacqueline is, what is the difference between the first class and the second class? So the first class is, actually it is a journey. It is the whole commercial excellence journey. But those of you who have gone through Marketing 101 may be familiar with the 4 Ps of marketing. So the first course on product and pricing analytics is the first 2 Ps. So basically the first course focuses more on launching, developing new products and innovation, as well as product development and the whole product portfolio kind of analytics. So that is the first 2 Ps of marketing. The second course on analytics for commercial excellence is focusing more on the commercialization, the go-to-market journey. So after the product is produced, how do you bring it to market? How do you analyze the success and track the performance of your products? And how do you make use of the other 2 Ps, which is place and promotion? And some people say there's a 5th P of marketing, which is the people. How you make use of all these organizational resources to help you go towards that, commercial excellence journey. Yeah. Okay, Jacqueline, I hope I answered your question. We look forward to seeing you at our product and pricing analytics. And if you have any question, you can reach out to us, and then our information is on the website. Yeah.
Yeah, sure.
Yeah. Okay.
So with that, we appreciate your feedback pertaining to this webinar session. So do give us your valuable feedback, constructive feedback via this link and QR code.